Read the question. In the circuit shown, resistance R is kept in a chamber. Maximum power transfer theorem idea is what I'm bringing. Value of R for which power dissipation in it is maximum. Tell me what should be the methodology. There are cells are there, no? So 10 plus 5, 15 volt, and here 10 ohm is there. So what is the equivalent? It should be 15 volt, and here 10 ohm will come. This is R. Here 5 volt, and this will be 10 ohm. Is asking value of R for which power dissipation in it is maximum. What will be the value of R? So I think we made certain rules. Can you remember? So one thing you can do, one thing, find out expression for power as a function of R, then differentiate, you'll get the required answer. So what is the one general methodology is? You calculate I1, I2. Then get expression for I1, I2 in terms of R. Then what is the power dissipated? I1 plus I2 whole square into R. So now find out I1, I2 in terms of R. Substitute here. Then dP by dR equals 0. You'll get the value of R for which power dissipated will be maximum in this resistor. And you'll get the value of R. Any other alternative method is you can, where all cells are there, replace with an internal resistance. Where all cells are there, replace with internal resistance. You can see this. Here cell was there. Here one cell is there. Then proceed like this. Then where you are finding out the value, so between that resistor R, then what is the effective resistance as seen by that resistor? 10 ohm, 15 ohm, and this is the terminal C and B. Here the cell which was there shorted. So what is RAB? RAB should be equal to 15 ohm, 10 into 15 by 10 plus 15, 6 ohm. It should be equal to effective resistance. This should be the value of RAB. There's a one easiest method. Whatever the type of circuit, you can use this one. Or else what you should do, mathematical approach. What is the mathematical approach? Calculate current through the resistor R in terms of capital R. Then what is the power dissipated? I1 plus I2 whole square by R. Then differentiate this equal to 0. You'll get the value of R. You'll get the same answer.
Was it 15, sir?
Be 5, sir. RAB will be 5.
5 ohm will come.
Yes, sir.
25.
Both are 10, sir.
Oh, both are 10, no? Both are 10. Yeah. And then it will be 5 ohm. I think either of approach, please do follow this. Which one convenient? Even see, this is applicable for any bigger, even 3 loops are there. This is valid. Even if I bring one more loop here, no problem. You have to calculate what is effective. Where all cells are there, replace with internal resistance. Of course, sir, is this internal resistance? We are not sure. We are just telling this is a branch resistance. Any internal resistance are there, replace with that and proceed. 3 loops come. I think this will be lengthier. This will be much easier. You have to remember the techniques. This is very important. Okay, there's a first part of the problem over. So we'll get answer 5 ohm, leave it. And now come for temperature of R when power dissipation is maximum. And you come for the next part of the problem. That everything is kept in a chamber where temperature is 20 degrees Celsius. This whole circuit. The initial temperature and resistance of R is 50 degrees Celsius. And 15 ohm respectively. I'm going to vary this. And as I keep on decrease the resistance and at one particular value, the power dissipated across it will be maximum. So what is the value when it is equal to 5 ohm? The rate of change of resistance with temperature is 0.5 ohm per degree Celsius. And the rate of decrease of temperature of R is log 3 by 100. log 3 all divided by 100. It is that value is time the temperature from the surrounding. Assume the resistor loses heat only in accordance with the Newton's laws of cooling. K is closed at T equals 0, then find. What shall I do for next one? The temperature decreases is telling. So therefore I'll write it expression for R is equal to R naught minus dr by d theta into temperature difference delta T, delta theta. What was initial 15 and dr by dt is equal to how much? 0, 1 by 2. So that temperature difference. So when power dissipation is maximum, is asking the temperature. What is the resistance when power dissipation is maximum? 5. So this will be temperature difference is 20 degrees Celsius. So what should be the temperature of that resistance? Surrounding temperature is how much? 20 is there. Temperature at that instant.
30.
30 or 40.
50 minus 20, 30 only.
Yeah, that should be. So 30 degrees is what temperature at that instant. Are you getting now? So now, what is the question? At least you are able to understand. I'm going to vary this resistance by ohm by varying the temperature of it. The initial temperature and resistance is and 15 ohm. The rate of change of resistance R with temperature is, and the rate of decrease of temperature R is temperature difference something. As I vary the temperature of this resistance, its resistance, as I vary the temperature of this R, the resistance will change. Due to change in resistance at one instant, it will have maximum power. So the temperature at which it will occur will be 30 degrees Celsius. Time after which power dissipation will be maximum. Time is asking from where to bring the time. I think Newton's laws of cooling only. So d theta okay, assume Newton's laws of cooling. So therefore, this average temperature difference. And these are very popular problems. Huh? These are, so this will be, what should be the temperature difference initially? 50 and this will be 30. Solve it, you'll get the time at which temperature difference will be